All right, so welcome back to your favorite inorganic tutor YouTube channel. Today, basically, we want to look at how to determine whether a function is indeed a one-to-one or not. All right, but before I begin, let me give a very big shout out to Mr. Rad and then Enoch, and finally my cameraman Mohammed. All right, so now let's look at how we can deal with a function, whether it is a one-to-one or not, right? So let's look at this particular function on the board. So for us to know whether this particular function f of x equals negative 2x cubed is a one-to-one or not, we have three methods. But here I want to take us to the algebraic approach. All right, so here we have to assume whether f of x1 is equal to f of x2, right? And this holds if and only if x1 is equal to x2, all right? So if this is going to hold, then x1 should be equal to x2, right? So here we say that x1, I think we have minus 1 here, so minus 2x1 cubed minus 1 should be equal to minus 2x2 cubed minus 1, right? So here we have to determine whether x1 is equal to x2. So here negative x1 cubed should be equal to negative x2 cubed, because this cancels out, right? So we still divide by minus 2 minus 2. Then we have x1 cubed should be equal to x2 cubed. Here we still have cube on it, so we can take the cube root on both sides. So when we take the cube root on both sides, then we have x1 equals x2, right? So indeed, this particular function is a one-to-one function since x1 is equal to x2. Hence, we can conclude that the function f of x, which is equal to negative s cubed minus 1, is indeed a one-to-one function. All right, so let's tackle another problem and see how we can deal with that one too. All right, so B, the next problem is we are given that variable a and b is not equal to 0. So variable a and b is not equal to 0, and we have to show that all linear functions are one-to-one. All linear functions are one-to-one. So we know that linear functions are functions that has a degree of 1, right? But here we have been given a hint that the function is equal to as plus b. But assuming we were not given this function, we have to know that all linear functions has a degree of 1. So this would be the function, right? So here, let's assume that f of x1 is equal to f of x2, right? So if that is true, this will only hold if and only if if and only if x1 is equal to x2, right? So if this is going to hold, then let's put it inside a function and see that this will work, right? So we have ax1 plus b should be equal to ax2 plus b, right? So we know that this will automatically take off this, right? And so we have ax1 should be equal to as2. And this also takes off this, the a. So we have x1 equals x2. And this has been proven, which shows that this function, the linear function ax plus b, is indeed a one-to-one function, right? So let's check the third problem. The third problem. So the third problem is g of x is equal to s squared plus 2, right? So this particular function, we want to determine if in this function is a one-to-one or not, right? So here we have to also assume, so let's assume that f of x1 should be equal to f of x2, right? This can be a, this can be b, in either way, right? So this will only work if and only if x2 x1 is equal to x2, right? So let's take the function, right? So we have x squared, which is x1 squared plus 2 should be equal to x2 squared plus 2, right? So we take off this. You know that when this crosses, we have the 2 going off. So we have x1 squared should be equal to s2 squared. So taking the square root on both sides, we know that when you take the square root of a square number, it's going to be a plus or minus, right? So we have plus or minus square root of s2 squared, right? So we have x1 is equal to plus or minus s2, right? So here we cannot conclude that the function is a one-to-one because this value can alternate at any point in time. This value can be minus 2 or plus 2, right? So this function here is not a one-to-one function. Hence g of x equals s squared plus 2 is not a one-to-one function, right? So the moment you have a square in your operations, then you have to understand that it's going to take a square root of it, right? And the moment you take a square root of a number, it's going to be plus or minus, right? And you know that plus or minus will either be -2 or whatever number it is. It's going to be either side of it, right? So this function is not a one-to-one function. So let's look at another problem and let's look at how we can deal with that problem as well. So the next problem is h of x is equal to 3x minus 7. Right. So this as well, I want to determine whether this particular function is a one-to-one function, right? You can pause the video and also give it a try, right? So here, we also assume, let's assume that f of x1 is equal to f of x2 right? So if this is going to be true, then x1 should be equal to x2, right? So here we have 3x1 minus 7 should be equal to 3x2 minus 7, right? And we know that this negative 7 will go off. So we have 3x1 equals 3x2. And this is automatically x1 is equal to x2. So we know that this particular function as well is indeed a one-to-one function. So let's look at our final problem on how to determine whether a function is indeed a one-to-one function or not. Right. So our last problem is k of x is equal to e power x. Right. So this particular function, we are to determine whether it is a one-to-one or not. Please don't forget to pause the video and give it a try. Right. Good. So here, let's assume that f of x1, or here we have k. So we can say that let k of x1 equals k of x2. Right. So if that is true, if this function is going to be true, or if this assumption is going to be true, then x1 should be equal to x2. Right. So that is true. Then let's go ahead. So we have e power x1 should be equal to e power x2. Right. So we are not there yet because we want to make sure that x1 is equal to x2. So what do? We take the natural log on both sides. We take the natural log on both sides. That is the ln, right? On both sides. Right. So ln of e power x1 is equal to ln of e power x1, right? And we know that the power rule, we have to take the exponent to the back of the ln, right? So we have x1 ln e should be equal to s2 ln e. And we all know that, or we are aware that ln e is equal to 1, right? So if ln e is equal to 1, then we have x1 into 1 should be equal to s2 into 1, right? So we have x1 is equal to x2. And that concludes that this particular function k of x, which is equal to e power x, is indeed a one-to-one function. Please don't forget to pause the video as you watch and then give it a try by yourself. When you get it, you'll be happy. Don't forget to subscribe, press on the notification bell, and I'll feed you with more content. Bye.